So this is going to lead us into the next example on page 47. We're going to go ahead and try to evaluate this function in terms of its limits from the left of 0, the right of 0, and then overall at 0. So it's very similar to the last one we did, except this time the coefficient in front of our theta variable is 3. And again, if we tried direct substitution of 0, we'd get sine of 0, which is 0, over 0. So again, we have that indeterminate form. Unfortunately, we cannot use a trig identity, we cannot factor, we don't have square roots to use a conjugate, and we don't have multiple fractions to simplify. So we don't really have the algebraic properties or tools necessary for us to do this by hand. There is a way to do it by hand, but we're not actually going to spend the time to do it in this course. If you are interested in that though, just let me know and I'd be more than happy to go over why these limits actually exist algebraically. But for now we'll go ahead and use our calculator. So we'll go ahead and instead of just a single x in there, we'll type in a 3x divided by a 3x. If you go ahead and hit your table options, you most likely have the same x values in there from previously. So the moment you change your function in y1, it should change the values for you. But it looks like we're actually left with the same values from our previous chart. So this is going to make evaluating the limit pretty simple. Again, we're approaching 0, so we'll find that in our table. And as we come in from the left, we get closer to 1. Come in from the right, we get closer to 1. So the overall limit would be getting closer to 1. So this brings us to kind of an interesting fact here. Notice how in the last example on the previous page, we did not have those coefficients of 3, but now we do, and we still happen to get the same limit. So we can make some type of inference or educated guess about what this trig limit actually does. So the limit as theta or x, whatever variable you want to use, as that approaches 0, okay, and it has to be 0 according to this limit, if you were to take the sine value of a theta being multiplied by a constant divided by the same theta value being multiplied by the same constant, this limit will always be 1. So as long as those coefficients match each other and your limit is approaching 0, this trig limit will always be 1. So this is going to be a special limit identity, I guess if you want to refer to it as that we're going to go ahead and use in this lesson. If we try a very similar one, we're going to go ahead and check out this function, and again we're going to be approaching 0. So if we try direct substitution first, cosine of 0 is 1, and it looks like we'd get 0 over 0. So unfortunately, there's no trig identity we can use here. There's no way we can factor it or use a conjugate or use fraction properties. So we'll go ahead and utilize the graphing calculator. So we'll clear out the previous one and we'll type in 1 minus cosine. Make sure you put the whole top in parentheses because we're dealing with a fraction, and we'll divide it by x. So taking a look at your table, you most likely have the same values in there as previously, so we'll go ahead and jot down the results. So this E on your calculator is scientific notation. That's just telling you you have to move the decimal. It looks like 4 spots to the left and then 5 spots to the left. So we'll have 0.0005 and then 0.00005. And then if you continue to look, we have those again, but just for positive values. So taking a look at 0, somewhere right in there, if we approach from the left, it looks like we're getting closer to 0, and then from the right, looks like we're getting closer to 0 as well, so our overall limit would be 0. So this is another special trig limit that we're going to utilize in this section. The limit as x approach, or we'll say theta, as theta approaches 0, if we have 1 minus the cosine value of theta times a constant over the same theta times a constant, that will always be 0. I know we didn't take a look at a specific example. For instance, if this was cosine of 3 theta divided by 3 theta, you could play around with that on your calculator, but it's going to work the same way that the sine limit did above. for this one right here. So if you want to take a look at some other examples and check it out, you can, but as long as those coefficients are the same for either one, we're going to have these specific results. So if you could please jot those down and remember them for tomorrow when we go over some more practice examples of these. We're definitely going to have to remember and utilize those to our advantage.